The journey to create an integrated circuit (IC) begins with innovative ideas and the collaboration of top experts at design centers worldwide. Here, engineers and scientists work together to design complex circuit diagrams that integrate billions of microscopic transistors. These diagrams serve not only as the blueprints of ICs, but also as the foundation for every modern technological device, from smartphones and self-driving cars to satellites in space. The main material used in this process is silicon, extracted from quartz sand, a widely available resource that requires advanced purification technology. Once processed to near-perfect purity, silicon is cast into large crystal ingots and sliced into thin wafers. These wafers form the foundation for the subsequent stages of production, where modern technology meets human ingenuity. Once the wafers are prepared, they are transferred to clean rooms, where the environment is meticulously controlled to prevent dust or contaminants from interfering with the wafer surfaces. These clean rooms maintain an environment thousands of times cleaner than ordinary laboratory air. Staff members wear specialized protective clothing to ensure a pristine environment is maintained. In the clean room, photolithography technology is used to transfer the circuit diagrams onto the surface of the silicon wafers. The wafers are coated with a light-sensitive material and then exposed to ultraviolet UV light through a photomask. The UV light etches precise circuit patterns onto the wafer surface, creating intricate designs that are smaller than a strand of hair. Areas not protected by the photomask dissolve and are removed, leaving behind the exact circuit layout. This critical step turns the design blueprint into a physical circuit. After the circuit structures are etched onto the wafers, the process of ion implantation begins. This step adjusts the electrical conductivity of each transistor by introducing special atoms, dopants, into the silicon structure. These dopant atoms are implanted with high precision, and the wafers are then heated to high temperatures to stabilize the atoms and integrate them into the silicon crystal lattice. This process transforms silicon from a basic semiconductor into a highly efficient platform for transistor operation. Next, the transistors are interconnected using a network of ultrafine copper wires. Copper is deposited into pre-etched grooves on the wafer and polished to remove excess material. This creates a precise and insulated network of connections that allows electrical signals to flow seamlessly between billions of transistors. This system of connections transforms individual transistors into a cohesive, high-performing integrated circuit. After completing the manufacturing process, the wafers undergo a series of rigorous quality control tests. Using electron microscopes and advanced monitoring technologies, engineers examine every detail, from the atomic structure of individual transistors to the accuracy of the copper connections. This thorough inspection ensures that every chip meets the highest standards, with no flaws that could compromise performance or durability. Once the wafers pass quality checks, they are cut into individual chips, each of which is a fully functional integrated circuit. These chips are then mounted onto frames and sealed with protective coatings. The packaging process ensures the chips can withstand harsh conditions during transportation and operate reliably in electronic devices. This final step prepares the chips to be integrated into the countless technological devices we use every day. The production of integrated circuits is a marvel of science and technology, where creativity meets absolute precision. From designing circuit diagrams, refining silicon, utilizing photolithography and ion implantation, to quality control and packaging, every step contributes to the extraordinary achievement of the semiconductor industry. These tiny chips are not just the foundation of technological devices, but also a testament to humanity's remarkable progress in overcoming challenges at the atomic level. The semiconductor industry is truly an indispensable pillar in the digital age, driving us further into the future.